Welcome to qnawire.
Part A of the given problem: to successfully launch a rocket, let's say we have a rocket here, from a ground, the fuel is consumed at the rate that results in a thrust big enough to overcome the gravitational force G downward. The thrust of a rocket is given by T is equal to R times V relative velocity, where R is the rate of fuel consumption and VREL is the relative velocity or the speed of exhaust gas related to the rocket. The exhaust speed we have VREL is 1200 meter per second. For the thrust, that is equal to the weight, which is mg, and the mass, capital mass, is 6100 kg. We must have a T thrust is equal to RV relative is equal to the mg. From here, R will be mg divided by V relative. Putting the values, we get the rate of fuel consumption to be 50 kg per second. Part B of the problem. With additional effect due to the gravity, we can write RV relative velocity minus mg is equal to m times a. From here, acceleration is 21 meter per second square. Then we can write the rate of a fuel consumption R to be capital mg plus a divided by V relative. Substituting values, 3100, no 3 zeros, 9.8 plus 21 divided by relative velocity of 1200 meter per second. This gives us the rate of fuel consumption to be approximately 1.6 times 10 to the power 2 kg per second.